What's up, guys? This is VeerMath&More here, and today we are going to be continuing our limit series, and this will be part 2. So we're going to be starting off with this limit right here, and it states to find the limit as x approaches infinity for root x minus 7 divided by 6 minus 5 root x. So you write down your starting limit, and the way we're going to solve this is we're going to employ a method called dividing by the largest degree variable, and in this case the largest degree variable is root x. So we're going to divide by it root x. So the root x over root x is 1. Negative 7 over root x is just negative 7 over root x. 6 over root x is, like I said, 6 over root x. And negative 5 to root x divided by root x is negative 5. Now, if you haven't realized, we can substitute x now in, because we're now going to be dividing by infinity. So in reality, you cannot divide by infinity, because that would mean to divide by such a large number. But from what we have learned so far in calculus, we can assume that dividing by infinity results in a number becoming 0, since you are dividing by such a huge lump sum. Obviously, this is because 1 divided by 10 is more greater than 1 divided by 100, and on and on and on, until you get 1 divided by infinity, which is equal to 0. That's what we assume. So before we couldn't do it, because then we weren't dividing by infinity. It'd just be root infinity minus 7, which we don't do here. So we plug in infinity, and it'll just go everywhere where x is, like usual. And remember, dividing by infinity, regardless if it's square root infinity or 2 infinity or whatever, it just becomes infinity. So this can become 0, this becomes 0, so it just becomes 1 over negative 5, which is the answer, making it negative 1 over 5. So yeah. So we're back with our next question, and it will be finding the limit as x approaches 0 for x squared minus x divided by x minus 3. And you're thinking, okay, Ranveer, what method are we going to use? Are we going to factor? Are we going to multiply by the complex conjugate? By the conjugate? Well, what are we going to do? Are we going to use squeeze theorem? And in reality, we cannot solve this limit. And no, this isn't because I'm a bad math person necessarily in this case. It's just the fact that this limit does not exist. So how do you know? Well, just to prove it. Let's prove it right now. So the definition of the limit is such that as the limit of some x approaching a plus, which is so basically a function, right? Let's say this function right here, if it has a whole, or our point limit, it should equal the limit from this side and the limit from this side. Therefore, the limit of this point is possible. So to denote the left and right side, we call this the right hand side because it's approaching from the positive, and the left hand side because it's going to be the limit as x approaches a to the power of minus, you could say, or negative, because it's approaching from the left hand side. So really, this is just right hand limit and left hand limit. You should already kind of know this. So we're going to evaluate our function at 3 plus and 3 minus. That's the way I say it. I don't know how else you say it. Sorry if I'm saying the wrong thing, but just keep it simple like that. 3 plus and 3 minus. And all we're going to do is, I just substitute in 3 plus, and that's the way you do it. So you're going to want to substitute 3 plus in, so you get 3 plus squared. And here you will treat it as 3 times 3, which is just 9 minus 3. So that's just 6. Sorry, hold up. Oh, nope, you don't have to do that. Oh my god. Bloopers. Ah! Sorry. So we're going to do it 6. On the bottom, 3 to the power of plus, or 3 plus minus 3 is 0 plus. Now what does 0 plus mean? 0 plus means that, the way I think of it is that 0 plus means some really, really small positive, or some number which is just above 0. So 0.000000001, just above. And when you divide by a really small positive number, you're going to get infinity. So this is just equal to infinity. Woohoo! Now let's do our left-hand limit. And again, we're going to substitute 3 minus in. You get, again, 6 on the top. That will not change. But on the bottom, you're going to get 0 minus. Now what the heck is that? That is going to be, well, you can assume if we divided by some really small positive number, well, we're going to divide by some really small negative number, which means that this isn't infinity. This is negative infinity. Therefore, these two are not equal. Nope, this is not true. They are not equal. This isn't the same thing. So what we're going to do is we're just going to write the sentence. The limit does not exist because it is not being evaluated at the left and right side hand limits at the same value, which means that the limit cannot exist. This is just a basic definition of limit, and yeah. So in our last problem, we're going to find the limit as t approaches infinity for the cube root of t cubed minus 8 divided by 2t. And the way we do this is that we have to evaluate it at, since t is approaching infinity, we have to use a slightly different method. This method is going to be dividing by the largest degree variable on the denominator. And what this does is this allows us to evaluate the limit without having to deal with the finicky gimmicks of infinity. So on the bottom we have t. That's our only variable, therefore we divide by that. So we're going to get 2 on the bottom. On the top, we divide by t. But you're thinking, okay, is that just t squared minus 8 over t? Nope, that's t cubed, because we're entering a cube root. This, or this, well, which is what we're doing, is equal to this. So we have to divide by t cubed. In this case, it doesn't really make a difference, but you have to be correct, obviously, when you're doing mathematics. So we divide by t cubed, or t, and we get 1, because t cubed over t cubed is 1, minus 8 over t cubed. Now we're able to evaluate t as approaching infinity. And you're like, how? Well, that's because any number divided by infinity is going to be equal to 0. Because we're dividing by such a huge number that the fraction goes to 0. So we plug in our approaching value, and we get 1 minus 8 over infinity divided by 2. And since we know that this is just 0, we can put that down in our limit, and it just becomes the cube root of 1 minus 0, which is just 1, because the cube root of 1 is 1, divided by 2. That's how you do this problem. So that was the end of the video, guys. Thanks for watching, and I'm going to be uploading a challenge problem through the YouTube post type thing, where I can like type text and show you guys a problem. And it's going to be a problem which I find can be pretty challenging, even for somebody who has experience with limits. And I'm going to have you guys try to attempt it, and then my next video will be explaining how you solve that. And I feel like it's a pretty lengthy process, as it took me a good 4 minutes, and that's on average longer than it normally takes me to approach a problem. Anyways, that was all for this video. Thank you for watching, and we'll see you next time. VeerMath&More, out.